Sarah, fast.
To me, the country is like
What?
there are two meanings. There is a meaning in English, there is a meaning in English. In Arabic, so it's in English.
She's taking her meetings, right?
That's like my
You know?
Oh,
Peace.
yeah.
Okay, should we start?
Yes.
I think it's already started. Okay, so now that we have finished motion in 1D, so today we are going to start with motion in 2 dimensions, okay? So, yes? The graph? The slope? Where?
The one we're gonna do is like this. Something is on a slope, like that, right?
Yeah, no. That will be discussed in Newton's laws of motion, okay? So, the spreadsheet that we shared with you, you guys have asked me to start with electricity and magnetism. So, for that I need vectors, okay? So, first I'll finish the vector portion and then we'll come to magnetism. Is that fine? Okay. So, in this motion in 2 dimensions, what we will be covering is, we'll be covering vectors, okay? Then we'll also be covering the projectile motion, and then of course, something about the relative velocity, okay? So let me first of all start with vectors. Can you tell me what are vectors? We have discussed it in the class. Yes? These are those quantities for which to understand you require magnitude and direction. If both are present, then only you can understand these quantities. If they are not present simultaneously, we cannot understand these quantities. Is that fine? So, vectors are quantities that have magnitude and have direction. Is that fine? And how do you represent these vectors? You represent these vectors by drawing an arrow. Is that okay? Now this arrow has a tail. Okay? It has a starting point. And it also has this arrowhead. So you need to understand that the length of the arrow gives you the magnitude of the vector. For example, I am saying force is equal to 10 newtons and it is along east. Then I have to draw an arrow whose length is giving me 10 newtons, the magnitude. Is that fine? And the direction of that arrow should be eastwards. Is that clear? Clear? Okay. The orientation of the arrow will give the direction and the length of the arrow is proportional to its magnitude. That's what you have to understand. Clear? No problem in this? Okay, for example, the HMS boat, Mac boat face, sails due east with a velocity of 10 meters per second when there is no wind. So when there is no wind, there is a boat which is going due east with a speed of 10 meters per second. Can you show its velocity vector? Yes? Its velocity vector will be an arrow whose magnitude will be what? 10 meters per second and the direction will be due east. So here it is, see? The boat with a velocity 10 meters per second and it is due towards east. Is that fine? On a certain day, a westward wind of 3 meters per second blows. Now you need to understand, what is a westward wind? A wind that starts from west and goes towards east. Is that fine? For example, they ask you about an eastward wind. What do you mean by eastward wind? It's a wind which starts from and goes towards. Is that clear? Very important. So we have a westward wind, so that means it starts from the west and it is going towards the east. So, and the length of that arrow should be how much? 3 meters per second. So you need to understand, If 10 meter is a little bit longer, then the 3 meter will be a little bit shorter. Is that clear? So what is the net? Then we say draw vectors representing boat's velocity with no wind, which is this, with wind, which is this, and the resultant velocity vector of the boat. See, when the boat is sailing towards east and the wind is also towards east, so the velocity of the boat will increase. The direction will be same, isn't it? The magnitude, the length of the arrow will be much bigger. And can you tell me how much bigger we have to draw it? Yes. If there is 10 and then again 3 in the same direction, so we'll be having 13 meter per second. The length will be much longer and the direction will be same. Is that clear? Now this is the composite vector. This is also called as the resultant vector. Is that clear? Can you draw these vectors? A vector A, which is 4 newtons, and it is 60 degree above the positive x-axis. Yes? We have to draw a vector whose length is how much? 4 newtons. So it's a force and it is 60 degrees above the positive x-axis. Now you need to understand. Whenever angles are given, it is very important to understand the direction of the angle. Remember, whenever angle is measured in anti-clockwise direction, your angle has to be taken as positive. Is that clear? And whenever angles are measured in clockwise direction, the angle has to be taken as, is that fine? So here he is saying 60 degrees above the positive x-axis. That means if this is the positive x-axis, okay, this is the positive x-axis. So what we are going to do is, we are going to draw an arrow whose length will be 4 newtons and it will be inclined at 60 degrees above the positive x-axis. That means from here, go in anti-clockwise direction by 60 degrees, okay, and then draw an arrow whose length will be 4. This will be your vector A. Is that clear? Is that clear? Similarly, we have vector B. Magnitude is again 4 newtons, but the angle is 120 degrees with the x-axis. So is the angle positive or negative? Yes? Positive. So when it is positive, you have to take it from the positive x-axis, but go in which direction? Anti-clockwise direction. Is that fine? So when you measure it in the anti-clockwise direction, you will have to draw it something like this. From here, go 120. So this is 120 degrees, and here you have to draw another arrow of the same length as that of A, because the magnitude is same. Is that clear?
But doesn't the angle doesn't have to be accurate, right? It doesn't have to be 100% accurate.
The length? See, for example, for us, if this is 4 Newton, then this also has to be of the same length.
About the 60 and 120, they don't have to be accurate.
Yeah, they have to be.
How would we do it accurately?
With the compass or with the protector.
We don't have.
You have geometry box, right? It has a protector or a compass. No? You can use your iPhones as well to draw. It has a protector. It has a map, right? Rotate that by 60 degrees, you will get it. It's fine. Okay. See, 2 newtons. How much will be the length of the arrow? Will it be shorter than these two? Yes, it will be half actually. Why? Because they were 4 newtons. Is that clear? Because as I told you, if you are drawing, for someone 4 newtons might be this. For someone else it might be this. It depends on the scale that you have chosen. No problem with that. Fine. But then if this is 4 newtons, then when you have to draw 2 newtons, it will be half. If this is 4 newtons and if you have to draw 2 newtons, it has to be half. Is that clear?
Yes.
Okay. So we have to draw 2 newtons in the negative y direction. Now the negative y direction is downwards. So if this is full 4 newtons, so half is this much. So that is it. This is your 2 newtons and this will be your C vector. Is that clear? Is that clear? That is it. No problem in this? This is very basic. This is something I think you have done vectors in the school as well, right? So I'm sure that something that you have not done is going to come up. Then there is something called as the vector components. Okay? See, you need to understand. Whenever we have a vector, this vector has effects in different directions. For example, I have this box in my hand. When I apply some force like this, see, when I apply some force, it will go like this. But at the same time, do you understand it has covered some direction in this way? And do you understand it has also covered some direction, some distance in along this direction? Yes? Isn't it? So when I am applying a force like this force is doing two things. One, it is taking this box forward, and it is also taking this box forward in this direction, isn't it? That is why this box is here. Is it clear? When I am, say for example, this is the box, and I am applying a force like this. So when it goes here, understand, it has gone somewhere here, and it has also covered this distance, and then it has reached this, isn't it?
Yes.
So there are components. The force that I am applying on this box has components, and these components have their own effect in different directions. Is that clear? So when you talk about the components of vectors in 2 dimensions, I'll be talking about 2 dimensions only, will not be discussing in 3 dimensions. So there have to be 2 components which will be perpendicular to each other, such that when we combine the components, we get the original vector. Is that fine? Do you understand this? We have a vector and it has 2 components, and the components must be perpendicular to each other. Is that fine? When you combine these components back, you'll get the original vector. Is that clear? So these 2 components have to be perpendicular. So that means if one is along x-axis, the other will be along the y-axis. If one is along z-axis, the other one can be along y-axis. If one is along z-axis, the other one can be along x-axis. No problem. But remember, the 2 components have to be perpendicular to each other. Is that clear? Okay, so here it is. Say for example, we have a vector v. Okay, it is at an angle of theta with respect to the x-axis. Okay, so this vector has 2 components. What do you understand by components? See, if you take a torch and just keep it like this over the vector, so do you think that this vector v will have a shadow casted on the x-axis? Yes? If you just take a torch and place it here, the light is coming in this direction, for example. So on this x-axis we will have its shadow, isn't it?
Yes.
Yes or no? The shadow of v on the x-axis is the component of v along x-axis. Is that clear? It is the shadow.
Shadow is what?
Shadow is the component of v along the x-axis. Is that clear? So this is the component of v along x-axis. We can call it vx. Is that fine? Similarly, if you take the torch and you place it here, see what will happen? On the y-axis we will have its shadow, isn't it? Yes or no? So the shadow will be somewhere here. Yes? This will be the y component. Is that clear? Is that clear? So when you combine the x component with the y component, you will get the original vector. Is that fine? Yes? So remember, when you do this, vx vector plus vy vector, the answer has to be the original vector. That is the concept of components. You are breaking a vector into its components, but when you combine these components back, we must always get the original vector. Is that clear? Is that clear? Okay. Now, what is the value of these components? In the previous classes, I think you must have done something in trigonometry, right? Have you done it? Trigonometry, sine theta, cos theta, tan theta, yes? So for example, I'm taking this triangle. Can you tell me how much is sine of theta? Sine of this angle? Is it perpendicular upon hypotenuse? Yes? Is it? So perpendicular is same as that of Vy, isn't it? So can I write Vy? Yes? Upon hypotenuse. Hypotenuse, it is the length of this vector v. But the length of the vector gives the magnitude of the vector, isn't it? So can I write it as simply v? Yes? So how much is Vy? How much is Vy? Yes? Is it v sine theta? Yes or no? So we have the y component. which is v sine theta. Clear? Similarly, if you take the cos of theta, you know that cos of theta is equal to what? Base upon hypotenuse. Now the base is Vx and the hypotenuse is again what? V, isn't it? So should I take it as Vx upon V? And therefore Vx will be equal to V cos theta, right? So we have the other component as well, Vx, which is V cos of theta. So the vector has two components. One is along the x-axis, one is along the y-axis, and the two components can be represented by V cos theta and V sin theta. Is that fine? Is that fine?
Yes.
Tell me, the angle of the vector was given with x-axis, isn't it? Therefore, with x, it is V cos theta. With y, it is V sin theta. Is that fine? But it is not always true. It is not always true. Sometimes the angle, this angle, will be given with the y-axis. In that case, what will be Vy? Yes? If the angle is not given with x-axis, it is given with y-axis. Like for example here, you have a vector, say this is A, okay? And this angle is theta. What will be AY? And what will be AX? Yes? Yes? See here, you need to understand, V has a component Vx along x-axis, but the angle was given with x-axis. Here the angle was not given with y-axis. So with x we have V cos theta. This time here, the angle is given with y-axis. So remember, AY will be A cos theta. No, it will be cos theta. Is that fine? And this will be what? A sin theta. Is that clear? So remember, we can conclude a point that with whatever axis the angle is given, cos theta is always along that direction. Is that fine? Here the angle was given with x, therefore x is V cos theta. Here the angle was given with y, therefore y is cos theta component. Is that fine? Is that clear? Always you can use this concept. Fine? Okay, then just try to solve this question. A vector of magnitude 25 meter per second acts at 60 degree above the horizontal. 60 degree above the horizontal. So we have a vector. Which is of course velocity, and its value is 25 meter per second, and it is at an angle of 60 degree above the horizontal. Fine? The question is, what are the x and the y component? What will be x? It will be V, it will be the cos component, isn't it? So can we say this will be V cos theta? Yes? And can we say this will be V sin theta? Yes, but what is V? How much is V? 25. So 25 cos of 60, and this will be 25 sine of 60. So therefore we have Vx as 25 cos 60, which is 12.5, and 25 sine 60, which is 21.7 meter per second. I think this is very basic and you have done it, right?
Yes.
Very good. Now let us come to one of the most important things, that is vector addition. How do you add vectors? Yes? Head to tail. Do you know, have you studied anything about the triangle law, the parallelogram law? Or you have just added vectors in terms of their components? I think you have added vectors only in terms of their components. Yes? Have we done it before? Addition? Multiplication? You've done it? But how? No, vectors cannot be divided. Okay, yeah. See, what is vector addition? See, in the previous example, what we did was, we broke down a vector into two components. That was called as resolution. And in resolution, we are getting two components, which when combined, give me the original vector. Is that fine? But sometimes, there are a number of people applying a force. And we want to see what is the net effect of the force. What is the total impact? In that case, we go for composition or addition of vectors. Is that fine? So what is addition? Addition is simply when you have two or more vectors and you want to find the net resultant. And you want to find the net effect of these vectors. Is that clear? How do you add them? There are some rules. One is called as the triangle rule of vector addition. Now what is this triangle rule? I'll not discuss the theory, I'll just come to the vector diagram so that you can understand. What is this triangle rule? For example, you have two vectors. One is A and then we have one more, that is CD. Okay? Someone is asking me, can you add them? I'll say yes. How are you supposed to add them? You need to understand. First step is you need to join the tails of these vectors. Remember this thing, very important thing. Whenever you have to add two vectors, join their tails. Okay? So when you try to join their tails, do we have to produce them like this? See? Yes? Isn't it? Now we are having this as the common vertex. Okay? After this, what you have to do? You have to lift this vector up and draw its equal vector at the head of B. Fine? You have to lift this vector up and draw its equal vector at the head of B. That means if this is your AB, now you lift this CD up, you draw its equal vector at the head of B. Will this be like this? Yes? Because you have drawn its equal. Now there are two vectors, tail to head and then again tail to head, isn't it? Yes? Now remember, whenever you have to add these vectors, the triangle law says, try to complete the triangle. Now the triangle will be completed by the third side, isn't it? This. Yes? Now this third side will be the resultant vector. That is, it will be the addition of AB and CD. But remember one thing, see, the order was A to B, that is from tail to head, then again from tail to head, but the resultant is in the opposite order, it is head to tail. Do you understand? It is the reverse order. So remember, AB plus CD will give me the resultant, but this resultant will be given in opposite order. The order is not same. It goes from tail to head, then tail to head, but here it is the reverse. It should be from D to A, but it is not from D to A, it is from A to D. Is that clear? This is the resultant. This is the triangle law of vector addition. For example, I'll show you one more example. There is A and then there is one more vector. Say this is A and this is B. Okay? For example. And the angle between the two vectors is theta, and someone tells you, can you add them? Can you find the net effect? What you have to do is, yes, you have to lift this vector up. One of the vectors you have to lift it up. Draw its equal at the head of it. Is that fine? Draw its equal. So when you draw its equal, that means you will lift this up and draw its equal somewhere here. Is that okay? And then try to complete the triangle. So the triangle will be completed by, for example, this side, isn't it? But in opposite order. So see, tail to head, the resultant will be in the opposite order. It should not go like this, it should go from this point to this point. So this is your resultant. Is that clear? Yes. Is that clear?
But there's two triangles now.
Yes?
With two triangles.
No, only one triangle.
For the whole thing.
No, we ignore this because we have lifted it up and drawn it here. Okay, so there will be always one triangle. Is that fine? Now tell me, what about this? What about this? This is A, this is B. Can you tell me from what will be their resultant? Can you tell me what will be their resultant? Yes? How do you do that? Yes? What did I tell you? We have to lift one up, but such that what is the condition? I told you, join their tails. Are their tails joined?
No.
So we have to lift one vector, right? So we will lift this B up and we will draw another B here. Is that fine?
Yes.
Now we draw it here. See what will happen. What is going to happen? This is your B. Is that okay? But now there is a problem. It is from tail to head and then it is tail to head in the opposite direction. So we have to lift it again up and take it to the head of A. Is that fine? Is that fine? So when you lift this B up and you draw it here, it will be something like this. Correct? This is also B, no problem. Now you have two vectors. One is like this and the other one is like this. So can we complete the triangle? Yes, we can. The triangle will be completed by the third side and that will be something like this. Yes? Isn't it? But what will be the direction? Opposite. So what is the original direction? It is this, this. It should be like this, but it will be opposite. Opposite means this is the result. Is that clear? That means this A and this B are producing an effect which is equal to green. Is that fine? So two people are doing work. Instead of these two, ask green. Green will do the work of both the people together. Is that okay? That is the concept of addition of vectors. This is the concept of the triangle law because you have to form a triangle. Is that clear? What about this? What about this? This is A and this is B. Can you show me the addition or the resultant of A and B as per the triangle?
You can choose either A or B.
Yeah, it depends on you, whatever you want. You can lift anyone. But the condition is first join their tails and then shift one of the vectors to the head of the other and then form a triangle. Is that fine? Yes, try to do it. How did you lift it up? The heads are joined. You have joined the tails. Sine of tangent is defined, but for vector, force of tangents cannot be divided by force of right. You will not get 2 because vectors cannot be divided. Yeah? You can find tan from a triangle. Say for example, you take tan opposite by base. But this is magnitude. This is also magnitude. We are not dividing the vectors. Clear? You're dividing magnitudes. But whenever, even if you are finding sine, this is opposite by hypotenuse. But opposite you are taking dy, which is a magnitude. So sine, for example, what is sine of 30? 1 by 2. It's a number. Magnitude. No relation. So sine of any is a number. It doesn't have relation. Yes. Now try to But then you have not shown your direction. See, this is B. You have lifted this A up. Now we have forward. This and this. So the result will be in the third. It depends whatever you want. You can move on. Okay? So if you take this, then this is the direction is like this, right? There is see because in this case you lift it up, draw it there. Is it? Now the triangle will be completed by third side, you will find order is original order was like this, and this. Okay, so this was wrong. But your direction, you have to do the direction of the arrow. Just come. Just tell you what What is this? How is this?
No, this one just like
What did I say? You don't have, you cannot change the direction. You have to look into now, order join the tail. But to find the result, you have to mix this up now and keep it on the head. So this A will move in the next step like this. This will give it up. Now we're going to do the third side. This has to be reversed. See the order is anti-clockwise, right? It should be like this. But the result is in the opposite. So you're going anti-clockwise, right? And this is anti-clockwise. See, yeah, there's the same. So it should be like this. Right? But this third side is the opposite. So you reverse that. The rest should be the same. Is that fine? You done?
Yes,
I cannot even see it. Yeah. Okay, this is there. See. Where did I keep the pen? Yes. Now see, there is one more method. If you fail to understand how do you shift them, then there is much easier method called as the parallelogram law. Which law? Parallelogram law says simple things. See, what does it say? It says if you have got two vectors, say for example this is B and this is A. If you want to add them, what was the triangle law? The triangle law would say pick this up, plot it here, isn't it? And then complete the triangle, something like this, right? Correct? But parallelogram law says don't pick it up, don't try to form a triangle. Form a parallelogram. How? See. If this is B, this is A, what you have to do is you have to form a parallelogram with these two vectors. So your parallelogram will be something like this, isn't it? Yes?
Yes.
Then as per the parallelogram law, the diagonal of this figure gives you the resultant. Khalas. What is the diagonal? Diagonal is this, right? This is your resultant. That's it.
Then we will give the A.
Yes?
The A.
You don't have to do anything. That's it, yes. If this is angle theta, this is the resultant R. You don't have to do anything here. But remember, for parallelogram law, you have to join the tails of the vectors. Very important. Is that clear? Join the tails, form a parallelogram, show the resultant. This is the same actually as compared to the triangle law. It is just an extension. How? See, if you had to pick this A up, this A was going to be here, right? Because in a parallelogram, opposite sides are parallel and equal, right? So if this is A, you have, as per the triangle law, you have to take A here, right? So this is B, this is A. The resultant will be given by the third side, but in opposite order. So the order, see, what do you mean by order? Order means the direction. You are going in anti-clockwise direction, see? Like this, and then you are going like this. So the third side should be like this, isn't it? But the order has to be reversed. The direction has to be reversed. This is R. So triangle law and parallelogram law are one and the same things. It is just that in triangle law you have to form a triangle. In parallelogram law, form a parallelogram and find the diagonal. The diagonal will give you the resultant. Is that clear? So resultant is A plus B. Now tell me, you are adding two vectors, isn't it? When you are adding two vectors, what will you get? Will you get a vector or a scalar? You will get a vector, isn't it? But that vector has magnitude, it also has direction, isn't it? It has magnitude as well as direction. So we need to know what will be the magnitude and the direction of the vector. So for that we have a formula. Here is the formula, and you will be solving numericals on this. If you have two vectors A and B, and if the angle between the vectors is theta, remember this thing. You have two vectors A and B, the angle between the vectors is how much? Theta. Then the resultant as per the parallelogram law is given by the third side. Sorry, by the diagonal, but in opposite order, right? Isn't it? From the common vertex, very important, from the tail of the two vectors. You have to draw this diagonal from the tail of the two vectors. Don't take this diagonal. There is one more diagonal of the parallelogram. You don't have to take that diagonal, okay? Which diagonal you have to take? The diagonal from the common vertex. Is that clear? But what will be the magnitude of R? The magnitude of R is this.
The formula is for magnitude of R.
Yeah, for the magnitude of R. And it is how much? Square root of A square plus B square plus twice AB cosine of theta. It is A square plus B square plus twice AB cosine of theta, and you take its square root. That's it. Khalas. This is your resultant in magnitude. Fine?
What's the tan thing?
Yes. If you have to find the direction, what? What? If you have to find the direction. Now this resultant is at some angle with B, it is also at some angle with A, right? Yes or no? This resultant is inclined to B at some angle. this resultant is inclined to A at some angle, right? Let the angle, for example, be this angle be alpha. Okay? If you come to know alpha, don't you have the direction of alpha? That is the formula. The formula is tan of alpha, the tangent of alpha is given by B sine theta, B sine of original angle, which was theta, divided by A plus B cos theta. This is the formula for the direction. Yeah, this is for direction. Direction of R. This is for the magnitude and this is for the direction. Now, very important. If you come to know alpha, can you know this angle? Can you know this angle? This? Yes? This will be how much? Theta minus alpha, isn't it? So you have to find one of the angles. But remember, the formula is not same all the time. This formula will be same all the time, but this formula you have to be very careful. Alpha is the angle with A, isn't it? Therefore, the formula starts with B. So it is B sine theta divided by A plus B cos theta. Is that clear? But if the angle, for example, this is A, this is B, the angle is theta, and this is your resultant. And for example, this was alpha. Okay? Then we cannot use this formula. Then the formula will be changed. What will be the formula? See what will be the formula. Here the angle was with A, therefore we started with B. So here the angle is with B. So we'll start with A. So the formula for tan of alpha will be, yes, it will be what? A sine theta over B plus A cosine theta. Is that clear? That's how you have to change it. It just depends. It is your wish. With which vector will you take the angle? It is not fixed. You can take it with any vector. Okay? But remember the way of using the formula, because in numerical this will be asked. Is that clear? Fine. So remember these two formulas. This will be much easier for you to find the results when there are two vectors that you have to add. Okay? So here is our first question. Is it clear? Take a picture of this first. So tomorrow is your test, right?
Yes.
So all of you should be ready with kinematics. Not this, but
Did you
kinematics.
increase the time?
I did tell them, yeah.
How much?
1.5. So here is a question. See the question. Two vectors, 10 units and 5 units, make an angle of 120 degrees. Is that fine? The question is, find the magnitude and the angle of resultant with the vector which is 10 units in magnitude. Can you do this question? Yes? So what is the magnitude of A? What is the magnitude of A? What is the magnitude of B? And how much is the angle? 120 degrees, isn't it? Can we draw it in vector form? In graphical form? So will it be something like this? See, if this is A and this has to be B, correct? And the angle here is 120, right? Isn't it? What we have to find? We have to find the magnitude and the angle of the result. First, what is the formula for the magnitude of the resultant?
Square root.
Yes, very good. So the resultant would be square root of, yes, A square, which is 10 square, plus 5 square, very good, plus twice A into B, which is 10 into 5,
Plus
into cosine of 120 degrees. Is that fine? What is the answer?
503.
It is root 75? 5 square root 3. Is that it? Units. This is the magnitude. Fine? Now tell me, do you accept as per the triangle law or the parallelogram law, can you show me the direction of R? What did I say? Complete the parallelogram, isn't it? So let us complete the parallelogram. When you complete the parallelogram, will it be something like this? See? Yes? So what is the resultant? Which one is the resultant? Yes? The diagonal from the common vertex. Is that fine? So is this the resultant?
Yes.
Very good. Very good. So for this resultant, you know the value. See? 5√3. So if this is 10, this is 5, this has to be a little bigger, 5√3. Understood? Now the question is, what is the angle with 10? So then which one is your alpha? What is alpha here? Yes? Is the angle alpha this? Yes? Because he is saying what is the direct angle of the resultant with 10 units. So 10 is this, so alpha has to be this. Okay? So do we have the formula for alpha? Which formula will we use for alpha? Yes? Can we say tangent of alpha will be equal to, yes, tell me how do you start? Alpha is the angle with, so we are left with, so we have to start with, very good, formula will be B sine of theta upon, yes, very good, A plus B cos of theta. Is that clear? Is that clear? So tell me the values. B is 5, sine of 120 over 10 plus 5 cos of 120. Give me the angle, give me the value. Yes? Radical 3 over 3? So can I say it is 1 upon radical 3? Is that fine? That is 1 upon root 3. Is that fine? See? Radical 3 over 3, right? Is that fine? So I can write it as radical 3. And can I write this as radical 3 multiplied by radical 3? Can I? Bases are same, powers are? Okay, multiply on your calculators. Square root 3 into square root 3. No, it is easy for us to find 1 upon root 3 because we have to find alpha. What is radical 3 into 3? It is 3. Why? See? Bases are same, powers are added. 1 by 2 plus 1 by 2, that is 1. Khalas, this is 3. But this will help me to ease it. This will cancel. So we have 1 upon radical 3. So this is 1 upon radical 3. Is that fine?
Yeah.
Now, we have tangent of alpha as 1 upon radical 3. So for which angle is tan 1 upon radical 3? For which angle? Yes? For which angle? For which angle? Tan of? Yes, tan inverse 1 upon root 3. How much is that? 30. Tangent of 30 is 1 upon root 3, right? So alpha has to be how much? 30. So that means this resultant is at an angle of 30 degrees. Do you understand? This is the concept of the addition of error. When A and B were doing some work, one was applying 10 newtons, other was applying 5 newtons. Their effect is 5 root 3. Okay? And the work is being done at 30 degrees. That's it. Clear? So do you understand how to find the angle? Last question for the day. A weather balloon is released and rises at a constant speed. How much? 15 meters per second relative to the ground. So what will be the direction of the velocity? When the balloon is going up, what will be the direction of the velocity? Up. So can I say it should be like this? Yes, velocity. And how much is it? 15 meters per second. Very good. The wind blows eastwards. What is the eastward wind? It starts from the east but goes towards, very important, eastward doesn't mean towards east. that is due east. Due east is towards east. But eastward wind means it is starting from the east but goes to the west. Okay? So there is a wind as well which is blowing like this towards west, and the speed is 6.5 meter per second. Now what is the question? Now tell me, where will the balloon go as per our concept? See, someone is trying to go up, and the wind is going like this. Where will this balloon go? It will go somewhere here, isn't it? So how do you do that? We have to find the resultant, isn't it? So let us find the resultant here. What are we supposed to do by the triangle law? We have to lift this up and take it to the head, isn't it? So when you take it to the head, should I draw it here? 6.5, okay? Tell me which will be the resultant. Yes, which one will be the resultant? Yes, there's the velocity of the wind, there's the velocity of the balloon. Okay, which one will be the resultant? Yes, this side, isn't it? But what will be the direction? Opposite order, very good. So the order is anti-clockwise. So we have to reverse the order, we have to go clockwise. So our direction will be this. This is the direction of the balloon. Resultant velocity of the balloon. Is that fine? Is that fine? Can you tell me the magnitude? Yes, tell me the magnitude. Tell me the magnitude, very good. Square root, yes. Yes, tell me the values. 6.5 squared plus, yes, 15 square plus 2 times 15, 6.5. But cosine of? What is the angle?
90.
Exactly, it's 90. Isn't it?
Yes.
Because it is going here, the angle is 90. And whenever you have to check the angle between the vectors, join their tails. Okay? So now this will be 0 because cos 90 is 0, right?
Yes.
Cos 90 is 0, so this is 0. We don't need it. So how much is the resultant? Tell me the value.
16.3.
Yes?
16.3.
60?
16.3.
Okay, so the answer is 16.3
3.
meter per second. But how about the direction? How about the direction? For the direction, it is simple. See, don't confuse yourself. See, what I will do is, this is the resultant, right? I will take this wind and draw it here. No problem. Now let this angle be alpha. Now, as per the parallelogram law, if this is alpha, you know the formula, right? So this angle is 90. So as per the formula, tangent of alpha will be equal to, yes, alpha is the angle with VW. So we are left with VB, right? So we'll start with VB and then VB sine of theta divided by VW plus VB cosine of theta. Is that clear? The same formula, just that instead of AB we are using VW and VB. Fine? When you put in the values, what is sine of 90? 1. What is cos of 90? Is it 0? So we don't need this and we don't need this because it is 1. So whenever the angle is 90, you can simply use the formula VB upon VW, which is 15 upon 6.5, okay? How much is that? Tell me. Tan of alpha is 15 upon 6.5. 2.3? So how much is alpha? So we can say tangent of alpha
66.5.
is 2.3. So alpha is
66.5.
66.5 degrees. So that means your balloon neither goes up nor it goes towards the east, towards the west. It goes at an angle of 66 degrees. Okay? It goes like this. That's it. So this is the concept of the addition. Clear? I'll stop here. In the next class maybe we'll be starting with the subtraction of it. Okay? Thank you so much.